Alright, so we're going to be having a look at some more questions. These come from a 2014 University Calc 1 exam paper. These ones are a little bit harder than the three at the beginning. So question 4, we have if f of x is equal to x over x minus 2 and x is less than 2, we have to find the inverse. So the way we're going to do this, we're going to say this is y equals x over x minus 2, and then we're going to swap x and y. So this will give us x equals y on y minus 2. We're then going to solve this for y. Solve for y. This will give us the inverse. So multiply both sides by y minus 2. This gives us x, y minus 2x is equal to y. We will move the 2x to the other side, plus 2x to both sides. We'll move the y to this side. This will give us xy minus y is equal to 2x. We're then going to factorize the y. Y in front of x minus 1 should not be an equals here. Y times y in front of x minus 1 is equal to 2x. Divide both sides by x minus 1. And this gives us y equals 2x over x minus 1. So this is the inverse function. So of our solutions, A is definitely not correct. B is possible. C is definitely not correct. D is possible as well. And E is definitely not correct. So the answer is either B or D. Now, we have to be careful with this because at the beginning of the question we specified that x was less than 2. So this means this function was defined at every point less than 2. So if we think about this, if x is 1, you get 1 on 1 minus 2. We could sort of try and graph this if we want, but we can just think about some values. So for this initial function, if x equals 1, you have y equals 1 on minus 1, which is minus 1. If x was equal to minus 1, you'd have minus 1 on minus 1 minus 3, which would be minus a third. So we have y equaling minus 1 when x is 1. We have y equaling minus, well, when x is minus 1, this will actually be 1/3. So if x is minus 1, y will be 1/3. So we need to make sure that this range is maintained. In our question down here, so this range included minus 1 and 1/3. And so this means initially the range was less than 1 because the only two options here are x is either less than 1 or greater than 1. Given that we know it's minus 1 sometimes and we know it's 1/3 sometimes, it has to be less than 1. So therefore the answer to this question must be B. So now we have question 5. Which of the following is not a representation of the complex number I? All right. So complex number I is just this vector in the eigenplane. So we're just trying to work out which of these are that vector. So if we think about e to the I pi on 2, this is a vector of length 1 rotated counterclockwise by pi on 2, so this is the same. This is analogous to I. If we think about the conjugate of minus I conjugate, well, this is actually 0 plus 1i, and when you're doing conjugates, you're changing, sorry, 0 plus minus 1i, 0 minus 1i, we don't need the plus. And so the conjugate here, this is just, this is minus I is this implies that minus I conjugate is actually just going to be 0 plus 1i. So this is the same as well. This checks out. This checks out. So now we have to move to the trigonometric ones. So we have two cos I sines. And we have one cos I sine where the cos is 3 pi on 3 and where the sine is 3 pi on 2. That's immediately suspicious. It may be the case that it checks out, but immediately D is looking like the answer. So cosine of pi on 2 plus I sine of pi on 2. So this is really just an alternative form. When you're writing complex numbers, you can write them in a bunch of different ways. This is one of the ways that you can write these complex numbers. So we really need to convert this back to a standard vector form. We have to use the transformation formulas we have to get back to a normal vector to see if this is the vector 0i, which is essentially, when we say representation of the complex number I, really that is the vector 0, 1 in the eigenplane, right? Because the eigenplane y-axis is just numbers multiplied by I. So 0, 1 is the vector here, which we would often call 0i. You could call it 0, 1 as well, and just specify that the second term was the complex term. A plus bi will be common, and then the vector will be ab. So here we know that complex number z is equal to r times cosine theta plus I sine theta. A is r cosine theta and b is r sine theta, where a is the first term here and b is the second term. So here we've got cosine of pi on 2. So the r value in this formula is obviously 1. So 1 times cosine of pi on 2, well, cosine of pi on 2 is 0, so this is 0. So a in this case is 0. B is r, which is 1, times sine of pi on 2. Well, sine of pi on 2 is 1. So here b is 1, and this is what we need, right? The b value here in the vector, because we have a plus bi, and this reduces to the vector ab. The coefficient of the y-axis term in the complex plane is 1. And so this checks out as well. So A is correct, B is correct, C is correct. They're all the same as the complex number I. D was immediately suspicious because it's also in cos I sine form. So this is cos 3 pi on 3 plus I sine 3 pi on 2. This is not going to be the complex number I. It's not going to be the complex number I for several reasons. Cosine of 3 pi on 3, this is just cosine of pi. So this is cosine of pi. Cosine of pi is minus 1. So you have an a value in this case, so this one is not the same. Therefore, which of the following is not a representation of the complex number I? It's going to be D. D is not a representation. So now we'll have a look at question 6. So this one's really easy if you know how to do this one. We are told a plus ib is the fourth root of a complex number z. What are the other three fourth roots? Well, if you have 4 roots, they're all at right angles. If you have 2 roots, they're opposite. If you have 3 roots, they have 120-degree angles between them. If you have 4, they have 90-degree angles between them. So if one of them is a plus ib, where this is a and this is b, it doesn't really matter what a and b are. Let's imagine that they sort of look similar. This vector is one root. Well, another root will be at right angles to this. And so this will be the vector going in. Well, first it will be the opposite vector. So we have minus a minus b. We have these ones. So this will be 2. So one of them will be a plus ib. One of them will be minus a minus ib. And if we look at the sets of solutions here, they all have minus a minus ib. Now, it may be the case that these sort of look like this. If a and b are the same, this will be diagonals. If they're not, we have to be careful with the other solutions. If a or b is larger than the other. So we will have 2 more solutions. One of them will be over here, and one of them will be over here. Now, these 2 will not have the coordinates a minus ib and minus a plus ib. They will have, the a and the b will be swapped for these 2 vectors. So let's imagine a is larger than b. This will then be a, this will then be minus b. So one of these will have vector coordinate minus b plus ia, and then the other one down here, this value will be b, this value will be minus a, it will have coordinate b minus ia. So we need a minus b plus ia, a minus a minus ib, and we also need a b minus ia. So this appears from the answers we have here. B minus IA appears in D, minus B plus IA appears in D, minus A minus IB appears in D. So from the look of it, the answer here should be D.